Hi sir, I'm Cadet Third Gas Donor during Bisinupaw, BSME 2 Charlie. Now I will reporting about the marine refrigeration. What is marine refrigeration? Ship refrigeration system play a vital part in the ships carrying a refrigerated cargo and because for the crew or passengers. Like for example in import and export, usually the ship carries a dry or fresh fruits and to deliver around the world. In order to maintain the freshness of the good, the ship has a refrigeration room where the goods was stuck temporarily, and also for the crew and passengers of the ships. They have also a refrigeration room where their food stock to prevent decay and also will long last. Refrigeration prevents any damage to the cargo or decay of the perishable foods like growth of microorganisms, oxidation, fermentation, and drying out of cargo. Now I will show you a video of where was the marine refrigeration located and also their parts and uses.
Hello guys, so it's our second day on board and we are here in the vegetable room wherein we're having icing on the evaporator. And for today I'm going to show you on how to fix this kind of trouble and where to start and what are the main cause of this problem. So come and join me in this new learning. So just like what I have said, the first thing that we suspect every time that we have this evaporator icing on the grill, then we need to check the refrigerant level, and upon checking, so the freon is in good level. So I've decided to check the meat room and the fish room evaporator, which I found out that it is just a normal evaporator condition. So we rule out this area. Why? Because as you can see, in a normal setup, I have this two compressors. One is standby and one is running. So from the compressor, it will actually go to your discharge side, which is passed through condenser, water cooled, and then it will go to service valves, to sight glass. Okay, the normal way to your discharge side, and then pass to the heat exchanger, and then it will only be separated in each and every room which is having the solenoid valve. So if this is normal in the condition of the evaporator grill, the refrigeration system for this is in good condition, because these are in good condition. So we can now focus on the evaporator section of the vegetable room, which is from the solenoid valve to the TXB to the grill and to whatever cargo or commodity you have in your vegetable room. So the problem is only coming from this side only. That is why I check first the solenoid valve. So in checking, I use my favorite tool, which is the permanent magnet. So I can hear a clicking sound, and then the solenoid coil is magnetized. So I can say that the solenoid valve is okay. since it is a vegetable room, so it doesn't have the manual defrost option unlike the freezer room. So I defrosted the system using the water. So after thoroughly cleaning the evaporator grill, I have decided to run the system and see how it will respond after this. I want to check if it is only a moisture from the vegetables or really having a problem on the mechanical section. I want to see the condition of the system on the next day. But as soon as the system runs, there is already a buildup of ice after the TXV. So the next day, I checked again the unit. In which I have found out that the grill is covered with ice again. So this time, I will use heat gun in melting the ice on the TXV. And then I have decided to adjust it with one full turn. It is important that you should have a markings on whatever you are doing on the TXV. Since there is an icing on the grill, I need to lower the superheat of the TXV. So this time I don't need to thaw the ice on the evaporator grill because I am sure that there is already a problem with the TXV. I just need to wait on how the TXV will respond after the adjustment. So I let it run for around 6 hours straight. So after we adjusted the superheat and now it's running well and no more icing. Before, as soon as we started the system, this one will get frosted already. So now it's okay and everything looks fine now and no more development of ice in each and every coil. So I'm planning to make another video which is all about the common troubles that you will be facing in your refrigeration system. Always remember to be familiarized on the system so that you will not get lost in the middle. Provision refrigeration is very important on board as this is where we stored our food on board. So everyone will be waiting for you to fix this system.
The refrigerant gas is compressed from low to high pressure inside the compressor. The compressor can be compared to a pump that conveys vapor in the refrigeration circuit. Usually, the compressors are driven electrically, connected to the motor via belt. Refrigeration compressor is generally a reciprocating type. Larger systems have multiple cylinders with an unloader system using the suction pressure as its signal. The vapor is sucked by the downward stroke of the piston from the low pressure side of the evaporator discharge. The upward movement of the piston compresses the vapor, which leaves the compressor at a different pressure, and the extra energy applied on it causes strong superheating of the vapor. Oil separator. The high-pressure superheated refrigerant vapor coming out of the compressor will go to the oil separator to remove oil traces from the refrigerant. An oil separator ensures oil return to the compressor oil sump. It prevents compressor breakdown caused by lack of lubrication, increases compressor operating life, protects against liquid hammer in the compressor. The oil separator maintains a high coefficient of condenser and evaporator performance by almost completely removing oil deposits from their exchange surfaces. The oil separator consists of internal baffle plats arranged along the path of refrigerant. As the refrigerant flows through the separator, the baffles will rapidly reduce the gas speed and create the conditions required for the separation of the oil from the refrigerant. As the oil is heavier than the refrigerant, it gets collected at the bottom of the separator. The bottom portion is provided with outlet pipe, which is connected to the suction of oil compressor crankcase. There is a floating operation needle valve arrangement, which opens the valve once set level of oil reaches inside the separator. The bottom of the separator may be provided with permanent magnet, which will hold all the metallic impurities, which may stuck the needle valve or can damage compressor internal parts. In a typical refrigerant condenser, the refrigerant enters the condenser in a superheated state. It is first desuperheated and then condensed by rejecting air to an external medium. The refrigerator may leave the condenser as a saturated or subcooled liquid, depending upon the temperature of the external medium and design of the condenser. The most common type of condenser used in marine refrigeration systems is shell and tube type condenser. The refrigerant flows through the shell while water flows through the tubes in single to 4 passes. A separate tank, which will act as a receiver, can be integrated with the condenser. There might be a vent connecting the receiver to the condenser for smooth drainage of liquid refrigerant. The shell also acts as a receiver. Further, the refrigerant also rejects heat to the surroundings from the shell. The most common type is horizontal shell type. After passing through the condenser, the liquid refrigerant then goes through the filter, whose main purpose is to remove the moisture from the refrigerant. Its other important function is to remove fine particles that can possibly block the expansion valve. A sight glass is also provided in the pipeline, which allows the operator to ensure that it is only liquid refrigerant and not a liquid gas mixture going to the expansion valves. On some designs, a water indicator is incorporated. Expansion device. Pressure in the receiver is much higher than the pressure in the evaporator because of the compressor pressure increase that has occurred prior to condenser. To reduce pressure to the same level as the evaporator, a device must be inserted to carry out this process, which is called throttling or expansion. This device is a throttling or expansion valve. The most common type used on ships' refrigeration system is a thermostatic expansion valve. It consists of a diaphragm, which is connected to the spring of the valve stem and the valve. The upper portion of the diaphragm is connected to the capillary tube, whose one end is connected to the bulb attached to the outlet of the evaporator containing small amount of liquid in a part of the bulb. The rest of the bulb, the capillary tube, and the space above the diaphragm in the valve housing is charged with saturated vapor at a pressure corresponding to the temperature at the bulb. If the temperature of the evaporator outlet is more than normal, it indicates that the refrigerant is superheated due to lack of refrigerant. The liquid in the bulb is temperature sensitive and it will exert pressure on the diaphragm, opening the valve and allowing more refrigerant to go to the starved evaporator. Evaporator. Evaporator is a phase change heat exchanger which consists of pipes arranged in loop and a fan to supply the low temperature from the evaporator to the surroundings. The refrigerant inside it will evaporate because the heat will be transmitted from the refrigerated hold to the evaporator. As the incoming liquid travels in the evaporator, it immediately cooled down to the evaporating temperature, which is also due to low pressure created by the compressor suction, with the result that the surrounding air from the hold at a higher temperature is able to cool down and transmit its warmth to the evaporator. This cool surrounding air is further spread in the room by using a fan.
And that's all, sir, for my report about the marine refrigeration. I'm Kalad Third Class Donor Junior Bisino po, BSM Me Too Charlie. Thank you, sir. God bless.